Today in math class we've got lesson 34, recognizing and extending arithmetic sequences. Take a look here at our new concepts. We've got a couple definitions that are highlighted in blue. As we read through this, make sure that you keep note of those definitions because we're going to apply those in each of the different examples. Sequences of numbers can be formed using a variety of patterns and operations. A sequence is a list of numbers that follow a rule, and each number in the sequence is called a term of the sequence. Here are a few examples of a sequence. 1, 3, 5, 7. Notice it goes up by 2 each time. So each of those increases by 2 is a term of the sequence. The next one, 7, 4, 1, -2. It's going down by 3 each time. So you could continue that. That's what these dots mean. If you would continue to roll in that pattern, you know what the next term in the sequence is. This one, for example, is 2, 6, 18, 54. Something that is different happening here. Here we were adding and subtracting. Now you might have some type of multiplication that's happening. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, 54 times 3 would be our next term in the sequence. Here's another one. 1, 4, 9, 16. This one goes up by 3. This one goes up by 5. This one goes up by 7. Maybe you can see that there's a subtle change that's happening each time it's going up by those odd numbers in this sequence. The next term would be the next term in the sequence. In the above examples, the first two sequences are a type of sequence called an arithmetic sequence. An arithmetic sequence is a sequence that has a constant difference between two consecutive terms called a common difference. So this one was plus 2, plus 2, plus 2, minus 3, minus 3, minus 3 as those common differences. To find the common difference, choose any term and subtract the previous term. In the first sequence above, the common difference is 2, while in the second sequence, the common difference is -3, like we just showed you. You can kind of see how they draw that out. They say, well, the difference between those, or the gap between those where this loop is where you have a positive or a negative value. That's an arithmetic sequence if it's increasing by being positively added or subtracted from each time. If the sequence does not have a common difference, then it's not an arithmetic sequence. So one of the parts that we're trying to do today is to simply recognize what those arithmetic sequences are. So we have to be able to tell, is it arithmetic or not, based on it increasing or decreasing by that same amount, that common difference each time. In example 1, it says determine if each sequence is an arithmetic sequence. If yes, find the common difference for the next two terms. So here we want to look at each of these sequence of numbers and try and find what the next term is based on what we see that there is a common difference. So 7, 12, 17, 22. What is it going up by each time? Or using the strategy that we just learned, take a term and subtract the previous term. So 12 minus 7 is 5. Does it go up by 5 each time? So 7 plus 5 is 12, 12 plus 5 is 17, 17 plus 5 is 22, 22 plus 5 then must be 27. In our solution then it says 12 minus 7 equals 5, so we found the common difference. Another example, 17 minus 12 is 5, 22 minus 17 is 5. If you look at any one of those and you subtract the previous term, it should be the same difference each time. We can see that it is, and then we can then calculate the next term in the sequence and go on as follows. 22 plus 5 is 27, 27 plus 5 is 32, 32 plus 5 is 37, and it follows this pattern. Letter B, 3, 6, 12, 24. Notice the difference here. 3 to 6 is 3, 6 to 12 is 6, 12 to 24 is 12. Notice there's not a common difference because if you subtracted, 12 minus 24 is 12, 12 minus 6 is 6, and 6 minus 3, you don't have a common difference. There's a pattern in this sequence, but it's not an arithmetic sequence. There's no common difference. The first term of a sequence can often be denoted as A1. So it's given this designation with the variable A. Because it's got this little subscript 1 right here, we're calling that the first term. That little number indicates what term it is in this sequence. The first term is A1, then the second term is A2, the third term is A3, and so on. The nth term of an arithmetic sequence is denoted as an, where this is the variable number. If you want to find any number, any number in the sequence, you can plug that value in and try and find what that value is. To find a term before that term, it's often denoted as an minus 1. For example, if n equals 6, you're looking at the sixth term. In order to find the sixth term, you need to know what the fifth term was, because if you know what the fifth term was, you know the common difference. You add that common difference or subtract that common difference to find the next term. This diagram here shows you what this relationship looks like. For example, the first term in this sequence is 7, and in the common difference D is 4. So 7 plus 4 is 11. And you take 11 and you add 4, so 7 plus 4 gives you 15. And the next one, you're taking the previous term, 7 plus 4 plus 4 gives you 19. And then the previous term, 7 plus 4 plus 4 again gives you 23. And it's written out in this way, and instead of writing in this huge extension, you write it with this notation here, an minus 1. So if I know the previous term, I know that I have to add 4, and I can find any term in the sequence. Arithmetic sequences are represented by this formula. So where a1 is the first term, an minus 1 is the previous term, and d is the common difference. Okay? So in the arithmetic sequence here that's listed, 7, 11, 15, 19, this is 7. 7 plus 4 is 11. 7 plus 4 is 15. 7 plus 4 is 19, and so on. You can see where those common terms are in terms of A1 is 7, A2 is 11, A3 is 15, and A4 is 19. The common difference is 4. This gives us information to actually write out the arithmetic sequence formula so that I can find the next term in the sequence always by knowing the previous term. In example 2, it's going to give you another type of formula. So not to get these confused, an arithmetic formula is shown right here. This is now what's called a recursive formula. Use a recursive formula to find the first 4 terms of an arithmetic sequence where a1 equals -2 and the common difference is 7. So here you have an equals an minus 1 plus d. So here's the formula that is our arithmetic sequence. And then you're plugging in the values that you're given. The common difference is 7 for d, so 7 goes right here. And the first term is -2, so you write that in here. Then you'd have the first term plus the common difference to find the second term. -2 plus 7 is 5. Then you take that term, plug it in for the next term. 5 plus 7 is 12. So you have, as your recursive formula here, -2, 5, 12, 19. Notice it's going up by 7 each time. The difference between 5 and -2 is 7. The difference between 12 and 5 is 7. The difference between 19 and 12 is 7. And you can see how those are properly labeled right here. First 4 terms of the sequence, -2, 5, 12, and 19. The rule for finding any term in an arithmetic sequence can be developed by looking at a different pattern in this sequence. Here you have the formula for finding the nth term in the sequence. So in these first two, as it's described, the arithmetic sequence formula, or what we call the recursive formula, you can find the next term in the sequence. So you can always go in order from the first term and find the next term and the next term and the next term because you find the pattern, and then you just work on finding that pattern. For example, if my first term is 5 and my common difference is 5, you've probably learned this as your multiplication facts for 5s. 5, 10, 15, 20, 25. I can always find the next term by adding that common difference or subtracting that common difference. Now, what if I just said, well, what is the 5th term in this sequence, or what is the 10th term in this sequence, what is the 15th term in the sequence? Could you actually find it? Well, yes, and here's how. There's an equation that you use based on the information that you're given. You plug in that information and you can solve the equation for any term that you're trying to find, any number in this entire sequence. Here's an example from this pattern that shows you, well, the first term is 7, the second term is 7 plus 4, and it writes that out as knowing the previous term plus the common difference. If I know the previous term, I know what the next term is going to be. Well, if I don't know that previous term, I'm just looking for any term. I have to think about the number of terms that I have overall and what that common difference is going to be. Because a lot of times repeated addition, or subtraction in this case, is the same as multiplication. So you're going to see multiplication come out in the equation. Here's the equation where it says an, which means any term in the equation, can be found by knowing the first term plus the term that you're looking for minus 1, because you're looking for, say, the 10th term. You want to cut out the first term because that's already in there, so you're looking for 9 terms times that common difference. Okay? So each time you multiply by that difference, you're saying here's how many of these have been added, or here's how many of these have been subtracted, and then take that from the first term initially. Let's take a look at the example problems here in example 3 to find the nth term in the arithmetic sequence by using that formula. Use the rule an equals 6 plus n minus 1 times 2 to find the nth term and the 11th term. So I find the term number, where here it says 4 and 11, I just simply plug that in for n. In this example, 4 minus 1 is 3. 3 times 2 is 6. 6 plus 6 is 12. So the fourth term in this sequence is 12. Remember, the first term was 6 and the common difference was 2. So let's just try and match those up. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. The fourth term was 12. The 11th term, then, if I kept going, I could say, well, 12, 14, 16, 18, 20, 22, 24, 26, and I got to 26. Or I can use this shortcut, which says the 11th term, plug that in. 11 minus 1 in parentheses here is 10. 10 times 2 is 20. 20 plus 6 is 26. In letter B, it says find the 10th term in the sequence of 3, 11, 19, and 27. Well, here it doesn't give you what the common difference is or what the first term is. You have to kind of pick those things out from the information that it shows you. In this example, the first number that comes in the sequence is the first term, so A1 equals 3, and the common difference is found by finding the difference between each of these terms. What's 11 minus 3? That's 8. Here's your formula, you plug in those values. Here goes the first term, and here goes your common difference, and you've got always in between here n minus 1 that's being multiplied. It asks us to find the 10th term, so I plug in 10. 10 minus 1 is 9. 9 times 8 is 72, plus 3 equals 75. Letter C. Find the 10th term of the sequence 1/4, 3/4, 5/4, and 7/4. Looks like to find the common difference here, you're going to subtract 3/4 from 1/4. 3/4 minus 1/4 is 2/4, or 1/2. So the first term is 1/4, and the common difference is 1/2. So I have my equation written out just like this. Here's my first term, here's my common difference, and here's the multiplication factor that will allow me to find any term in the whole sequence if it's an arithmetic sequence. In this case, letter C says find the 10th term, so I plug in 10 for n. 10 minus 1 is 9. 9 times 1/2 is going to be 9 over 2 times, or plus 1/4, is going to give me 19/4. Example 4. The application for today's lesson is a seating for a reception. The first table at a reception will seat 9 guests, with each additional table seating only 6 people. Write the rule to model this situation. So here's an example. You're trying to plan out the space, the seating for maybe your future wedding at this reception, and the head table has 9 people, obviously the bride and the groom and all of the brides or the bridal party, and then you have everybody else sitting at smaller tables. So the first term is 9, and then the common difference is 6. To write that in the equation, you'd plug in 9 right here in this first space. You'd plug in 6 where the d would be in our common difference portion of the equation, and then you have the multiplication that's happening, n minus 1. In this example, it says, well, there are 10 tables. How many guests can you have? Plug in 10 for the value of n. 10 minus 1 is 9. 9 times 6 is 54 plus 9 gives you 63. So here's a real-world application of how that arithmetic sequence would be used. If you'd like some extra practice in your lesson practice, the very first two, A and B, ask you if it's an arithmetic sequence or not. This is 7, 6, 5, 4. Looks like it's going down by 1, so you'd say yes. B goes 10 to 2, 12 is up 2, 12 to 15 is up 3, 15 to 14 is up 4, so it's not an arithmetic sequence because it's not going in that same way. In letters C and D, you're using the recursive formula or the arithmetic sequence formula to solve. Here in letter C, it says use a recursive formula to find the first 4 terms in an arithmetic sequence, where A1 is -3 and the common difference is 4. So here you'd have -3 plus 4 is 1, plus 4 is 5, plus 4 is 9, plus 4 is 13, and you could keep going using that formula. In letter D, you're using the rule AN equals 14 plus n minus 1 times -3 to find the 4th term and the 11th term. We just practiced this with the arithmetic sequence. Here's where you have that equation again. You plug in the first term and the difference, then multiply by the term that it's trying to find. In this example, if you wanted to practice, you're going to plug in 4 and multiply, and 11 and multiply. And then you do the same for letters E and F. For your homework today, you're completing the practice problems that have been assigned to you for lesson 34. God's blessings. If you have questions, feel free to reach out.